Swayam Prabha. Digital India. Educated India.
Namaste, hello everyone. Welcome again to my NPTEL course on interior design. We are at the lecture number 23 today and we are still focusing on green interiors, and we are specifically going to talk about physics of light and chemistry of colors. It is a very comprehensive, important and technical lecture. I request for your time and attention because it is very industry oriented and you will find it very useful. So the broad contents for today, we'll talk about, lighting design, concept, functions. We'll talk about physics of light. We'll talk about vision and color perception within that. Then we will talk about chemistry of colors and we will try to understand the color wheel and what are the effect of color on space. We will also try to understand the photometric quantities and the transmission of light, the lead CI, the credits for daylighting, artificial lighting, what is LPD, and of course we'll see a comprehensive list of references. So let's start with lighting design and broadly trying to understand what are the concepts related to lighting design when we talk about interior design projects and lighting design associated with that. So it's important to understand the functions of lighting design. So it is practical as one of the most important functions, and it ensures visual comfort while performing a task. So if we look at a task or activity over here, there is a certain illumination, that is the lux levels required for us to be able to perform that task. So that is of course related to the functionality. So for the casual seeing, walking, talking, we require 100 lux. And if there is an exceptionally severe task such as watchmaking, it could be 2000 to 3000 lux. And this is a reference, from full moon to overcast sky to sunlight. But for simplification and for understanding in terms of lux levels, what are the requirements, for doing these functions, we can understand through this kind of a table. The other function of lighting design could be artistic, to create an ambience, mood, or psychological effect. Now, there is always this kind of a temperature association when we talk about lighting design, and we have touched upon it. There is also an association between light and color. So here, if we talk about these lux levels on this axis and temperature on this axis, we could classify too warm to too cold to comfortable as these three different zones. So this could be like a cold color that we see over here, and this could be a warm color which has association with warmth and some temperature. So there are a lot of interrelationships between color and light, temperature and light, temperature and color, interrelationships between these. And they do have implications on our mood as well as the functional aspects. So physics of light, when I say physics of light, we have some background from science, most of us, and we may have studied physics. So we have some understanding. And why I'm talking about physics of light? Because I always say interior design is a technical subject and it is important to have, some fundamentals clear. So just trying to understand what light is, and when we talk about lighting design, why do we really need to begin from this point? So basically, it is a narrow wavelength band of electromagnetic radiation from 380 to 780 nanometers from violet to red. So these are the colors, and this is the range for visible light. So if we try to understand the electromagnetic spectrum, there is a very, very minuscule portion which is the visible light spectrum. So, we have this visible light from this nanometer to this nanometer, and towards left it is UV, and this side it is infrared. So, if we try to understand this broad spectrum, we have cosmic rays, X rays, this is for, radio, broadcast bands, and so on. And this over here, if we look at this portion, this is the visible light. There is also a capacity of visual fields. We briefly saw this during lecture number 8. So we talk about the human eye and the capacity of visual fields. There is this focus vision, which helps us in, targeting, reading signs and signals. It gives us visual lead. Then there is central vision, which is for referencing path of travel, sight lines. And there is also peripheral vision, which helps us understand, motion and color changes. So it's very important to understand these fundamentals, and then we can really also establish, what are these sight lines, how do we focus on a certain aspect, what kind of lighting design is required to aid that, what is the functional aspect in terms of, the levels of illuminance, the lux levels, and so on. So we can draw some correlations once we understand the fundamentals. So let's talk about the human eye, and it has two kinds of receptors, cones and rods. So 6.5 million cones help perceive color. So we are talking about importance of color and lighting all the time when we talk about interior design. So this is how we perceive the colors. And there are 100 million rods that perceive only black and white but respond to minute quantities of light. So if we talk about day and night vision, we see mesopic, which is dim light vision, and it's also called the rod and cone vision. Then there is scotopic, which is night vision and primarily rods vision. And there is photopic, which is the day vision, the cones vision. So the cones of the eye are of 3 different types, and these are the primary colors in light, which are red, green, and blue. And that's how we are able to understand this day and night vision, and we are able to perceive and see things. So there is also, vision and color perception. There is a sensitivity of eye to color. We were talking about this kind of a range, for the visible light. And if we talk about the sensitivity of eye to color, the human eye's sensitivity is greatest around 550 nanometers, which is for the color yellow. Then we talk about color perception. The wavelength of light determines its color. Light containing all visible waves is perceived as white. Materials that have the same reflectance for all wavelengths of visible light and will not change the composition of light after reflection are known as neutral reflectors, and they will be seen as white, gray, and black. So when we talk about, absence of color in white, or we talk about neutral colors, or we talk about the maximum sensitivity of human eye towards yellow, which is a certain nanometer, of course, there is a profound science behind it, and that's why we are calling them physics of light and chemistry of colors. And we are trying to understand the human eye, our perception towards color, and vision and color perception, their interrelationships. Materials that are selective in their reflectance of wavelengths by absorbing certain wavelengths of the incident light will show color effect. So these are the kinds of impacts and effects we will get to see. Continuing with the color perception, we must have come across, several times RGB color scheme and, CMYK color scheme. So what are these and how can we try to understand them very briefly? Cameras, televisions, phones, computer monitors use the additive color model. The additive color model describes how light produces color. The additive colors are red, green, and blue, or RGB. The additive color starts with black and adds red, green, and blue light to produce the visible spectrum of colors. As more color is added, the result becomes lighter. When all three colors are combined equally, the result is white light. So if we look over here, the additive color, and there is this red, there is green, and there is blue. So there is RGB scheme, and their combinations give us certain results. And these are additive colors. Similarly, there are also, the subtractive colors. In the subtractive color model, pigment produces color using reflected light. This color model is used in printing, silk screening, painting, and other mediums that add pigment to a substrate. The subtractive colors are cyan, yellow, magenta, and black, also known as CMYK. Subtractive color begins with white and ends with black. As color is added, the result becomes darker. Now we are seeing silk screening, painting, printing. Here the CMYK is encouraged. And if we are talking about, using silk screen, some kind of silk screening for interior design projects, some wallpapers, some printing, this would be important for us to understand what is the difference between, the CMYK and the RGB color scheme. So we were talking about this red, green, and blue, and here the cyan, magenta, and yellow. So this is basically to understand the two major schemes that are utilized for different, visual related aspects and projects and different media, how they utilize it. Broadly talking about chemistry of colors and trying to understand further from where we left in terms of additive and subtractive. It would be interesting to, get to know about the color wheel because it helps us understand the color system and interrelationships between color very well. So it is a helpful tool to examine the relationship between colors. It represents the linear spectrum of visible light, the colors of the rainbow from red to violet, and joins the ends of the line to form a circle. The color wheel enables to visualize and define color combinations that work well together. So we get to know about the color harmonies. So if we look at the color wheel over here, we see the primary colors, which are the yellow, red, and blue. Then we see some secondary colors, orange, violet, and green, the one in the dotted. And then there are tertiary colors, which are formed by combination. So yellow, orange over here is tertiary, red, orange, red, violet, and so on. So this is the color wheel, and this helps us understand the primary, secondary, and tertiary colors. And we will also see what are the effects of different colors on a space and how could we pick and choose the color scheme for us. So to understand the color system in a very simplistic manner, because it could be very elaborate and technical, but putting things in a very, very simplified form over here. The Munsell color system, it describes each color in terms of, first one is hue, which is the color itself. Red, blue, yellow, green, purple, so on. Second one is the value, the subjective measure of reflectance, giving light or dark appearance to the color. And then there is chroma, which is the degree of colorfulness or the intensity of the color. Now we are talking about the value. Lighter values are called tints and darker values are called shades. And there are also tones. So tone is also denoted by intensity, but it is created by adding both white and black, which is gray. So it is slightly different from chroma. So chroma refers to the intensity or saturation of a color, essentially how vibrant or pure it is, while tone refers to a color that has been dulled by adding gray, meaning it has a lower saturation and appears less vibrant. For example, a bright sunny yellow would have high chroma, while a muted pastel yellow would be considered a toned version with lower chroma. So depending on the choice and depending on the typology or the function where that color has to be used, there are different options available and the designers could take a call. But it's important to understand what is a hue, value, chroma, tint, tone, shade, you know, because color is a very, very important element when we talk about interior design. And if we are able to have a hold and command on creating and selecting colors, it would give us an edge. In fact, there are a lot of countries, especially, Nordic countries and other parts of Europe, where the color designers are seen as experts, and there are demands and there are like career trajectories that people have followed focusing on color. So, if I have to sort of give an overview, the hue is pure pigment. Tone is a pure pigment with just gray added. Tint is a pure pigment with just white added. And shade is the pure pigment with just black added. So here, if we look at the hue, this is the pure color. Tint is the mixture of color with white. For tone, we have added gray. And for the shade, we have added black. So we have this whole range and plethora. And depending on, what is the functionality and what is the interest and where we are using it, we could pick and choose and create our own customized color palettes, for projects that we do. Again, tint, hue, tone, and shade. So there are a lot of colors and there is a huge variety within the color system, and the color wheel helps us understand these interrelationships and helps us, uh, pick the colors, understand their potential use, and also try to understand their proximity and association and interrelationships with the other colors. So going ahead with the color wheel, this is again another elaborate illustration. And here, if we look at the pure color, we again see these variations. So tint, tone, shade. And we see red over here, yellow over here, and somewhere over here, blue. And we have other color combinations which are present. So, of course, we can understand the different aspects like tint, tone, and shade. But there are more important things to understand in terms of the color system when we look at the color wheel. So, there is dyad using two colors, which are two colors apart on the wheel. There is triad using three colors equally spaced on the wheel. So, like this scheme, if you look at the yellow orange over here and this blue green, they actually are a part of triad. Then there is tetrad, which is a contrast of four or more colors on the wheel. So it helps us understand creating this system and which colors go well with the other colors on the color wheel. So there are complementary colors, there are split complementary colors, and it is a very, very detailed illustration which helps us understand this system. So complementary, then there is this split complementary, triads, and then the tetrads. So this is a very, very good illustration to understand these broad aspects. Then trying to understand neutrals. True neutrals are black, white, and grays. termed achromatic, meaning without color. But the interior design lexicon has expanded the meaning to include desaturated and less bright colors, particularly natural earthy colors, as part of neutrals, and they are used quite extensively in interior design projects. Then, color temperature and mood, like I was talking about. Each hue has its own visual temperature. Warm colors can make us actually feel physically warmer, and cool colors can make us feel cooler. So there are physical as well as psychological, implications on what kinds of colors we choose and then how they impact our mood. So if we look at the color wheel here, the warm colors and cool colors can be seen. So these are the warm colors, the yellows, the yellow oranges, and here the blue green, violet, blue violet. So there is an association, of color temperature with our mood. And then, if we try to understand the chemistry of colors, and we have seen the dimensions of colors, we have tried to understand the color system. Now, moving on, if we try to see what are the effects of colors on different spaces, we can see some of the predominantly used colors and try to understand, how do they impact the space and our moods. So, starting with red, it is associated with fire and blood and therefore connotes heat, force, intensity, of course, also danger. And therefore, we use, for a danger sign, a lot of times red color. When red is reduced to a tint, it becomes pink and loses some of its psychological intensity. Lighter pinks, in particular, are associated with femininity and delicacy. And when reduced to a shade, red becomes brown. So we can see this entire range. Orange. Red mixed with yellow produces orange. Orange tends to produce a cheerful response, which is why it is widely used in commercial settings in interior design industry. Orange tints include beige and tan, which are popular background colors, and shades include browns. Looking at yellow, among the warm colors, yellow has the least intense impact. It is considered less aggressive than red. It is the color of sunshine, happiness, activity, and mild stimulation. The yellow tints include creams, beiges, and light tans, which are considered pleasant background colors. Its shades include tans and browns. Then the brown. Browns are warm, dignified, and comforting. They can be rustic or refined. They carry positive connotations of wood, raw textiles, brick, and earth. They may also have associations with dirt and soil. Talking about green. Green is the warmest of the cool colors due to its yellow content. Its association with grass and trees makes green calming and restful to the eyes. Green is the most natural color with connotations of health and well-being. Tints of green share these characteristics in reduced intensity. Shades of green signify solidity. Talking about blue. It is the coolest of the cool colors and appears restful and calm. Its associations with sky and water suggest spaciousness, simplicity, and purity. So it adds to the volume. There is violet. Now, violet and purple should be approached with caution as they incorporate the conflicting values of warmth and coolness, dynamism and calm. Pale tints of violet are thought of as playful and feminine. Deeper shades of purple can be dignified, mystical. So they are also in vogue and used in different ways in interior design projects. Of course, white. White is not strictly a color, but is the result of the combination of all colors. Its absence of chromaticity makes it a symbol of purity, simplicity, clarity, cleanliness. White has also become a symbol of modernism, minimalism. And then also it helps in reflecting light because it's a light surface. It adds to the volume. And a lot of people prefer white for interior design projects and interior spaces. Black. That is another non-color, the opposite of white. Black is a strong color with implications of strength, or I would say black is a strong non-color, which has implications of strength, dignity, and formality, with implications of emptiness or gloominess. The contrast of black with white can be striking. And we are going to see the case of tiny houses and compact spaces and how the contrast of black with white helps in achieving certain functionalities in compact spaces. There is gray. Gray results from the mixture of black and white or from mixtures of complementary colors. Light grays do not have strong associations and are useful background tones for more chromatic colors. Darker grays share the characteristics of black, albeit to a lesser extent, of course, and can be authoritative or ominous. So, these are some of the colors and the kind of effect or association they have when we talk about their application in interior spaces. So when we talk about red, um, it suggests excitement, strength, energy. Orange, success, vibrance, confidence, sociability. Yellow, of course, happiness, cheer, creativity. Then there is green, healing, freshness, nature. Talking about the cool color blue, so it showcases peace, loyalty, more emotions that the humans can relate to. Pink is seen as the color of compassion, sincerity, sophistication, sweetness. Purple is seen as the color of royalty, luxury, spirituality, ambition. Then there is brown, which is rugged and raw and rustic and, dependable, simple. The non-color black, formality, for dramatic effects, for sophistication. And white is for cleanliness, simplicity, purity, honesty. And the different permutations and combinations of what you see and more can also be achieved, and they could also um, fulfill different functions and create different effects on the spaces that they are applied. Now, this is also a very interesting table, and it helps us understand, certain materials and the certain color palettes associated with them, and trying to classify them from very bright to very dark. So, this kind of a gradation and a sort of an understanding through this tabular format. So, anodized aluminium, white paint, plaster or white coating. These could be seen as very bright. Then there is brushed aluminium, and there are white acoustical panels, there are white tiles. They can be seen as in the bright in terms of these categories. Then we have the light birch, ash, maple. I'm talking about timber, pine wood, new concrete, light wood fiber. These could be put here as medium when we see this scale from very dark to very bright. Then there is mahogany, walnut, hardwoods. We discussed about these. The light grey carpet, earthenware tiling, oak floor. These would be under the category of dark. And then red brick, worn concrete, dark grey carpet. They could be very dark. So, of course, there is a profound effect of the kind of color we select and on the space where we are applying it. There is also color perception. And when we talk about color perception, we talk about colored light, apparent colors. So when we talk about colored light, it can be created by an additive process of mixing colored lights from different sources, with the resultant as the sum of the wavelength ranges of all the components. And then there is apparent color. It is the resultant mix of the intrinsic color of the object and the intrinsic color of the light source. So one scenario here, and then how we perceive color and the actual color versus the apparent color. Let's try to see briefly what are the photometric quantities, and I'm just trying to showcase some of these important aspects here, because when we work, on ground as part of industry, and we have to connect to different vendors, we have to look at technical brochures, we have to look at manuals, we should be at least aware of these important parameters and important terminologies which will come handy, when we work, especially focusing on green interiors, talking about lighting design, talking about VLT, LPD, U value, different kinds of glasses, and so on. So in an overview manner, I have just tried to put them today here. So when we talk about photometric quantities, these four are very crucial. So there is flux, intensity, illuminance, and luminance. And these are put here very simply. So when we talk about flux, it is energy per unit of time, and it is usually calculated in lumen. So if we look here at this incandescent lamp and this discharge lamp with certain wattage which is associated with them, and the amount of lumens which are produced, we see these kinds of numbers. Then there is intensity, which is flux emitted in a certain direction within a certain solid angle, and the unit is candela. Then there is illuminance, which is very important when we talk about the lighting design, when we talk about the concepts related to daylight, artificial light. It is flux received per unit of surface. It is also called as illumination, and the unit is lux, and it's basically a surface property. So it's very important to understand illuminance, and it's put here in a very overview manner. Then there is luminance. Now when we talk about luminance, it's flux emitted by apparent surface in a given direction. It considers source, so it has source properties. So these are the four major photometric quantities. And when we look at the light fixtures, we look at the technical specifications, we will come across, these kinds of quantities, their mention, and the kinds of units that we are talking about. So continuing with photometry, it is important to understand diffuse illuminance from the sky, and some other concepts which we will see. Illuminance from the sky received on a horizontal working plane from the whole hemisphere, excluding direct sunlight. So this is diffuse illuminance. Then there is direct lighting, which we achieve from luminaire or artificial lighting. And then there is indirect lighting. Illumination achieved by reflection, usually from wall, ceiling surfaces. So here we see these three types. Now the quality of illumination depends on these: color of light, color rendering, light distribution, luminance distribution, freedom from glare. Let's see transmission of light. And why we are talking about this is because there is a lot of use of glass and glazings, in our interior design projects. And we have to understand important concepts like reflection, absorption, transmission, and which kind of glazing or glass is appropriate for our projects. and how the transmission of light occurs, through different kinds of material, particularly glass, that we use quite heavily in our projects. So the incident light on an object is reflected in three ways, and these are the ways which we must have heard by now, or some of us probably haven't come across it, but yeah, these are some common concepts. So if I talk about glass, and here this direct solar radiation, some of it is reflected by glass, some diffuse solar radiation, some is absorbed by the glass. Then, there is component which is re-radiated and converted into another form. And of course, some is directly transmitted through glass. So when we talk about glasses like translucent glass, it is a glass with the property of transmitting light diffusely. So ideally, reflectance, absorbance and transmittance should be equal to 1 as per this equation. And we can pick and select materials keeping in mind these. So if we want to have a transparent glass, the reflection is 0. Translucent glass, like I was talking about on the previous slide, will have component of diffusion. If we are talking about an opaque glass or an opaque surface, the transmission will be 0. So therefore, these are the fundamental concepts. Therefore, we are talking about physics of light so that we understand some technical aspects. So we already see here transmission, absorption, reflection, and the ideal equation and the kinds of materials that could be selected and utilized for our projects. So if we talk about a clear glass and a tinted glass, this is the kind of data that we are going to achieve, 100% to 40% only in tinted glass. So tinted or filter glass, a glass with the property to reduce transmission of light or with the property of selective color transmittance. So we can accordingly select the kind of material that we want and what kind of lighting and what kind of lighting design we have to undergo for a project, for a kind of space, for a kind of whether it's functional or it's artistic, or what is the purpose for which we are selecting certain material and designing light or trying to achieve a certain light. So I was talking about some of the brochures. This one is from the Saint Gobain, and there are a lot of technical brochures and specifications like this. This is something known as special architectural glass. And here, this is glass, titanium blue, light blue green, what's the code, coating phase, thickness. Here, this is like 6 mm thickness, weight. Then there are light factors, solar radiation, shading, and these are some standards, ASHRAE. We will see the U value, SHGC, VLT, all of these in the coming slides. So light factors, transmission, percentage reflection, UV, within solar radiation, transmission, reflectance, absorption, and so on. So these are technical, and these are already there for us to refer to. And it's important to do market survey. It's important to be aware of such manuals and such resources which are available for us to learn from and look at. And we must be aware of these technical terms so that we can at least discuss them. And of course, with practice, we can also excel at those. So you see those numbers continued here. Then there are prismatic panels. So these are very, very interesting, unconventional choices that can be, accommodated if the project, demands these, and we could take advantage of this knowledge. So prismatic panels are thin, planar, sawtooth devices made of clear acrylic that are used in temperate climates to redirect or refract daylight. We see over here. So these kinds of panels are available. When used as a shading system, they refract direct sunlight but transmit diffuse skylight. So also used as a shading system. They can be applied in different ways in fixed or sun tracking arrangements to facades and skylights. Then there are laser cut panels. The laser cut panel is a daylight redirecting system produced by making laser cuts in a thin panel made of clear acrylic material. So these are the cuts. Then there are louvers. Louvers are classic daylighting systems that can be applied for solar shading to protect against glare and to redirect daylight. These are the louvers, and this is no glare within this area. Then there is light shelf. A light shelf is a classic daylighting system that is designed to shade and reflect light on its top surface and to shield direct glare from the sky. So this is the case of summer and this is the case of winter. The sun's angle is of course different in summer and in winters, and accordingly these shelves are used, and they are designed to shade and reflect light on the top surface and they shield direct glare from the sky. Then there are sun directing glasses, concave acrylic elements stacked vertically within a double glazed unit. Redirect direct sunlight from all angles of incidence onto the ceiling. So this is the inside and this is the outside. So this is again an interesting choice. Then there is zenithal light guiding glass. The zenithal light guiding glass with holographic optical elements redirects diffuse skylight into the depth of a room. This is another very interesting, choice for some interior design projects. Let's talk about lead CI because we are talking about green interiors, and let's focus on daylighting and artificial lighting because lighting is a very, very significant component when we talk about interior design projects. So we are talking about IEQ, the Indoor Environment Quality Credit 8.1, which focuses on daylight. And either we could use software simulations or manual calculations or, a light meter for calculating. So daylight illuminance should be 250 lux to 5000 lux on September 21st at 9 a.m. and 3 p.m. And these are taken as base values and references for software simulations. Then there is this equation for manual calculations. I am not telling this in too much detail, but this can be done easily. On-site measurement using light meter. So there are apps actually for both Android, iOS, and using a light meter, these calculations can be done on site. And I usually encourage this, and during my interior design course at IIT Roorkee, there is always an exercise which focuses on this. So actual daylight levels on site measured by a light meter should be at least 250 lux. So this can be managed on site. There is also a prescriptive method, and here we find out compliant window area and floor area for side lighting. So if this is the compliant window height This is normally the compliant floor width. So h to 2h. This is how it looks in plan, the floor area. H is to 2h. And this is an elevation, the compliant window area. So that's a sort of a prescriptive method that, at least till 2h we could have light if we design the window in this manner. And again, there are some references and tables which are already there for us to refer to. So when we talk about windows, they also have a lot of, subsets of information. So window head height, sill height, width, bay width, whether it's north, south bay, east, west, and so on, whether it's on a corner. So there are already some values which we could refer to when we do calculations, especially for prescriptive method that we just saw. Now, how much daylight is adequate? Guideline standards give minimum light levels required for different spaces. It is recommended to provide this using daylight to minimize use of artificial lights. So we must minimize artificial lights. That's very, very important, and it can be achieved through design and through careful selection of fixtures, materials, proper orientation, proper circulation, alignment of furniture, utilizing the positioning and placement of windows. So there are also guidelines and standards which help us understand how much daylight is adequate. There is LEED CI guideline, ASHRAE standards, NBC standards, the National Building Codes. And there are some recommended illuminance targets which are also there, and we can refer to sources. So for areas and activities listed over here, such as the passageways which require lux levels 40, to kitchen counter which could require up to 750. There are some standards already in place after a lot of research and validation which has been done. So the good design will use daylight to provide the recommended illuminance levels during the day. That's very important if we can utilize this to the maximum possible. Now, factors affecting daylight. So when we talk about daylight, I am essentially talking about glazing right now because it plays an important role in bringing daylight into the space. Therefore, it is very important to understand the properties of glass and these three in particular. So U value, which is concerned with heat gain or loss. The SHGC, the solar heat gain constant, which is again concerned with heat gain or loss. And then there is VLT, visual light transmittance, which is concerned with light. So this is light and here this is heat. So U value, less heat gain desired. So when I talk about U value, we want less heat gain. Similarly, SHGC, we want the less heat gain. We don't want, more heat to enter. And then there is VLT. Here we want more daylight to come. So we have to focus on these three and we have to understand these technical specifications. We have to look at those specifications when we, buy or procure or decide on selecting certain materials for our projects. And we must try to focus on reducing the heat gain and maximizing the daylight. So if I talk about a scale from 0 to 1, we want the U value as close as 0, SHGC as close as 0, and VLT as much as possible towards the higher side on a scale 0 to 1. So VLT, like I said, visual light transmittance, it is a fraction of visible light transmitted through the glazing. It affects daylight and visibility. Higher VLT is better for good daylight, like we just saw. A single pane clear glass has a typical VLT of 85%, which is quite high. So if I were to ask you, on a scale of 5 to 50, 5% to 50%, here which one is the VLT which corresponds to 5% and the one that corresponds to 50%? You can take a few seconds. Here it is, it's very simple, 5% and 50%. So more VLT, more daylight. Then of course there are interior design guidelines for daylighting and to help us understand how can we really maximize the daylight, the daylighting in the interior spaces. Light shelves can help throw daylight to deeper areas of the space. We saw the light shelf. Interior layouts can affect overall excess of daylight and views. Like, we talked about the retail spaces and how the layout itself can be a part of the good design strategy, including visual merchandising. Of course, whenever we talk about interior layouts, they can affect the overall excess of daylight, circulation, views, overall quality of, space, the experience for the user. Light colored flooring will also reflect light. Light colored finishes will reflect light better. Use interior blinds to control glare. So these are simple guidelines, but very effective. Now let's talk about artificial lighting, because of course we need artificial lighting also when there is no daylight. So now there is a credit as part of LEED CI for optimizing energy performance through lighting. And when we talk about artificial lighting, we have to think about lighting design and lighting controls in a manner that we are able to reduce the artificial lighting demand. So when we talk about lighting design, reduce LPD, lighting power density. I'll just show you after a few slides what exactly it is. And it has a lot of role for our interior design projects, especially when we are talking about lighting design and especially artificial lighting. So as per the LEED CI, the mandatory norm is 10% reduction from ASHRAE 90.1 benchmark. So there's a benchmark which is set up, and if we could have 10% reduction from that base value, that would be mandatory in terms of reducing the LPD. And of course, if it is 20 to even greater than 40%, that is optional but highly, highly commendable if we are able to do that. Lighting controls. Provide daylight controls for daylit areas. Provide daylight controls for 50% of lighting loads. Provide occupancy sensors for 75% of lighting loads. So we are trying to, reduce artificial light. So using occupancy sensors, many of us already must be aware by now. We use them in washrooms, even at our cubicles. When somebody is not occupying that space, the light would go dim or it would go completely off, and things like that. So here if we look at like one inventory to help us understand suitability of lighting control application. So from good savings to no savings, this is the kind of mapping. So let's say small office, open office which is daylit, and open office interior. Let's talk about occupancy sensors. They would give good savings for all three cases. And if I talk about daylight dimming, it will give good savings for these two cases, but not for this. So we have to strategize, we have to understand, and then we have to implement these measures. So I was talking about LPD, lighting power density, and it's not very complicated. It's a very simple formula to calculate LPD. So total installed watts of lighting per unit area, watt per square feet, indicates the lighting energy consumption. So very, very crucial when we are talking about green interiors and we are talking about lighting design, we are talking about, different aspects related to lighting, and we know it is significantly a part of interior design projects. So that's the formula. So if I have to give you an example, let's say building A has an area of 80,000 square feet and the lighting load of 60 kilowatts. Building B has an area of this much square feet, 2 lakh, with a lighting load of 120 kilowatts. Which building has the efficient lighting design? Of course, the answer is over here. So we do this simple calculation. And here the value is less. So less LPD, more efficient lighting design. So we are trying to understand these fundamentals. Less hue value, less SHGC, more VLT, less LPD. These are the ASHRAE 90.1 standards about which I mentioned a while ago. And these are the LPD values that have been put for our reference, and we can just see these already existing tables. So these are the building area types: office, gymnasium, hospital, workshop, school, university, and these are the LPD calculations in watt per square feet. So we can always refer to these, and then we can do the LPD calculation in the projects that we have designed or the spaces that we are using, even for our houses, our offices, and we can see how much is the difference from the base value, and if it is significantly high, what could be done, what strategy could be implemented to reduce it so that the lighting energy consumption can be minimized. These are more tables, more sources, and we have a lot of data available to refer to, against different kinds of spaces that we see over here: hospital, performing art theater, atrium, hotel, all of that, laboratory. More examples, different kinds of spaces, museum, workshops. So when we talk about lighting power density, the factors that affect lighting power density are types of light fixtures, total number of light fixtures, wattage of the light fixtures, something known as the lamp efficacy. So there are different kinds of light fixtures that are available in the market, from a compact fluorescent lamp to this kind of a fluorescent tube. There is something known as T5, T8. We have these metal halide lamps. There is halogen lamp that we come across. Sodium vapor lamp over here, and within that also high pressure sodium and low pressure sodium. Of course, there is LED, which is very, very popular and extensively used, in all kinds of projects. So now we talk about lamp efficacy. All lamps consume energy to emit light. Different lamps have different lumen output. So again, there's a very simple formula: light output in lumens divided by energy input in watt. That is the efficacy. Efficacy indicates the energy efficiency of a light source. So this is a very important, concept, and this we will come across when we work especially on projects that have a lot to do with lighting design. So now again, a small example: if we were to find out which lamp is energy efficient, and there is lamp A, it is a 20 watt lamp with 3000 lumens. Lamp B is a 40 watt lamp with 5000 lumens. So again, we just put this formula to use, and then we can see which one is more efficient. So the lamp efficacy of A is greater, and it is more energy efficient. So I showed you some of the light fixtures in, the previous slides. So these fixtures and luminaire, they have different efficacies. When we talk about the high pressure sodium and we talk about lumens per watt, it is, on a higher side amongst all of these on a scale from 0 to 100. There is metal halide, there is CFL, and we see the incandescent lamps have very less efficacies. So we are using them less and less, of course, because of, the they are not so energy efficient. So, and but here also, like, one has to see where we are utilizing these luminaire or fixtures. We cannot use high pressure sodium lamp everywhere, so that functional aspect has to be taken care of. But LEDs and CFLs do provide, of course, a better solution compared to conventional incandescent lamps. So here again we see some allowable luminous efficacy, and this is as per Griha. And here we see the light source and the lumens per watt. So for CFL it is 50, for fluorescent 75, metal halide and high pressure sodium vapor lamp, and then of course there are LEDs which are quite common and popular these days. So we did talk about LPD and we did compare, two calculations for two different buildings. But to understand LPD in a more comprehensive manner, we did talk about the factors that affect LPD, and we did talk about light fixtures and wattage and efficacy. So then we have to consider all these aspects and then we have to apply the formula. And then in watt per square feet, we can calculate it in a detailed manner. So this is one table explaining that. All light fixtures give out heat. We have been talking about this association between light and temperature, also color, temperature, and interrelationships between all of these. So this is incandescent. And here, if you look at heat versus light, this is the index. A lot of heat and very less light. And fluorescent, it is this number. For metal halide, it is this, and this for the HPS. So all the fixtures give out heat. Now let's try to understand day lighting and views, because they are also important when we talk about lead CI and certain numbers while calculating the green interiors aspect, and for designating our projects to be green, we do consider day lighting and views. So when we talk about day lighting and views to the exterior matter a lot. Providing a connection to the outdoors affects overall indoor environmental quality. And indoor-outdoor relationships of a space depend on the context, the interior layout, base building. And there is this credit for daylight and views, like I was telling. So provide daylight in 75% or 90% of regularly occupied spaces. Achieve direct line of sight through vision glazing for 90% of occupied spaces. We will see the visual glazing. So this is vision glazing, and here if we look at, this dimension where we have the effective window or opening installed, and this is the section which is vision glazing, and we are seeing this in elevation, and this is in the section. So sitting from here, I'm getting these kinds of views from the vision glazing. Determining exterior views. So there is this index that has been created to help us understand, what all spaces come within the lead boundary and the ones which do not fall under it. Let me try to show a zoom in picture. So this is the zoom in picture, and this hatch portion here is basically what is not included in the lead boundary. When we do, calculations for calculating the credits or the points associated with our project when we are trying to get designation for it as green interiors. So this staircase, lifts, other common areas. Then there are regularly occupied spaces, cubicles and functional areas. Non-regularly occupied spaces, some areas which are again not regularly occupied. And then regularly occupied spaces without views, the brown ones. So we have to maximize the views, we have to maximize daylighting, we have to give exterior views, and that's very much essential for the indoor environmental quality. And it does reflect on the tally of points when the calculation is being done for the project to be considered as green or not green. So this kind of demarcation and indexing, it helps understand the occupation of spaces and interrelationship with exterior views, etc. So some of the factors we could see and understand, under the broad umbrella of green interiors, especially focusing on lighting and color, which help us understand how, as designers, we can learn from these norms and practices, technical specifications, and we can be informed and we can take some responsible decisions and try to create interesting, vibrant, green interior spaces. I'm going to give this very interesting quote over here, which is given by the designer Victoria Hagen. Good design is all about the light. You want to create a space that is inviting and warm, and light plays a huge part in that. Layering ambient, task, and accent lighting creates depth and dimension, enhancing the beauty of your interiors. Next lecture, we are going to continue with green interiors, and we are especially going to focus on policies and incentives and materials and finishes. Some of the references for today, like I said, it is a very, very comprehensive, industry-oriented and crucial lecture. I have tried to put a lot of books and websites for references. Thank you so much. I'll see you next time.